Alright, so today we're going to look at Lecture 2 in Unit 4 under Gas Laws. For Lecture 2, we're going to focus on what is known as the kinetic molecular theory of gases, liquids, and solids. The essential question for this particular lecture is, what is the kinetic molecular theory? So by the time you're done with viewing this video, make sure that you're able to answer this question for the quiz that will take place during class. Okay, so let's start out. What is the kinetic molecular theory? Well, there are 5 postulates to the kinetic molecular theory, and all 5 of these postulates you need to become familiar with and make sure that you understand them. So let's take a look at each one of these. Postulate number 1 says particles of gases are not held in rigid positions like particles of a solid are. What that means is that in a solid, the particles that make up the solid are very tightly packed, and basically due to the fact that they have high attractive forces between particles and solids and very low amounts of energy. Whereas in a gas, the particles have a lot of energy, and that energy is going to break the forces in between those particles, cause those particles to spread out over a large volume, so therefore gases are not held in rigid positions like solids. In postulate 2, the distance between gas particles is very large compared with the distance between particles of solids or liquids. Just on the same idea is because the particles of gas have so much energy that they're moving very fast. The attractive forces between gas particles are zero, essentially, and therefore those gas particles are spread out over a large volume. In postulate 3, the distance between gas particles is very large, thus they can be squeezed together. This just makes the assumption that gases are able to be compressed. Gases are considered fluids, and they can be compressed into a smaller volume. And postulate 4 says gas particles are in constant motion and collide with the walls of their container, thus exerting pressure. They are in constant motion due to the amount of kinetic energy that they have, and they often collide with the walls of the container due to their motion. And when they do collide, as we've discussed earlier in this unit, that they exert a pressure on the container. And finally, in postulate 5, particles of gases are widely spaced, and attractive forces between gas particles are very small, which we've mentioned earlier. Therefore, gas particles are free to spread further apart. I think postulate 5 is extremely important to understand. The attractive forces in gases are very small or almost non-existent. That is due to the amount of kinetic energy these gas molecules have, so they're moving so fast that those forces are zero. Alright, now we can diagram and look at a model of the kinetic molecular theory here. As you can look at the solids, the particles that make up the solid, they're very compact, very tightly found in a rigid space. Solids have high attractive forces, so make sure you understand solids have high attractive forces and very little kinetic energy, or a lot less kinetic energy than you'd find in gases. So because of their low kinetic energy, the forces of attraction between the particles are very strong and keeps the particles in a solid, rigid position. In a liquid, liquids have more energy, kinetic energy, than solids do. Therefore, the attractive forces between particles in liquids are smaller than they are found in solids. This allows the molecules that make up liquids, or the particles that make up liquids, more fluid. They're able to flow more, and they're not held in such a rigid shape. And then as we add more and more energy to the liquid, those attractive forces become more and more closer to zero, or very small attractive forces between the particles. So essentially the particles begin to gain speed, and they move further and further apart from each other, and then they enter into the gas stage. And you can see the gases, very little attraction between the particles, and they're moving have a much larger amount of space in between those particles, as the kinetic molecular theory states. Okay, so what you need to do is walk away from this is be able to explain the kinetic molecular theory in detail. Make sure you know those 5 postulates very well and what they mean. Be able to draw a model of the kinetic molecular theory as you see on this slide here, and be able to describe the attractive forces between the solids, liquids, and gases, and the kinetic energy between the solids, liquids, and gases. And just to review one more time, solids have low kinetic energy compared to the other two, and therefore they have stronger molecular forces, or forces between the particles that hold them together. Liquids have more kinetic energy, the particles are moving faster, therefore there's less attractive forces between the particles, allows them to move more. Whereas in a gas, it has extremely high amounts of kinetic energy, the particles are moving very rapidly, therefore the intermolecular or attractive forces between particles is essentially zero. Alright, so make sure you understand this. Have questions, come with them to class. Review this video as often as you need to. And that is it for now.